The universe is vast and awe-inspiring, a seemingly infinite expanse that stretches beyond our wildest imaginations. It's filled with billions of galaxies, each teeming with stars and planets, each a potential cradle for life. But have you ever stopped to wonder where it all came from? What is the origin of this magnificent cosmos? How did this incredible expanse of space, time, and matter come into being? What sparked the birth of the universe? This question has puzzled humans for centuries, driving us to look up at the stars and seek answers. It is a fundamental question that speaks to our very existence, touching the core of our curiosity and our quest for knowledge. We yearn to understand our place in the cosmos and to unravel the secrets of its birth, a quest that has spanned generations. Throughout history, philosophers and theologians have grappled with the idea of creation, each offering their own interpretations. Ancient myths offered explanations rooted in the supernatural, stories that sought to make sense of the unknown. They often involved powerful deities who brought forth the universe from a state of chaos or nothingness, weaving tales of divine creation. However, with the rise of science, we began to seek answers grounded in observation, experimentation, and mathematical models, moving beyond myth and legend. We began to explore the universe with telescopes and particle accelerators, tools that allowed us to peer deeper into the cosmos than ever before. Our quest to understand the universe's origins became intertwined with the pursuit of scientific knowledge, a journey of discovery and innovation. This pursuit has led us to develop theories like the Big Bang, which provides the most compelling explanation for the universe's beginning, a moment of unimaginable energy and potential. It is a story that takes us back to a time when the universe was infinitely small and unimaginably dense, a singularity that marked the birth of everything we know. It is a story of cosmic evolution, of fundamental forces shaping the fabric of reality, a tale of transformation and growth. But even as we delve deeper into the mysteries of the universe, we are confronted with even more profound questions, questions that challenge our understanding and push the boundaries of human knowledge. How can something come from nothing? What are the laws that govern such a phenomenon? What existed before the Big Bang? Are there other universes beyond our own hidden realms that we have yet to discover? These questions challenge our understanding of physics and push the boundaries of human knowledge, driving us to explore new theories and ideas. The journey to unravel the universe's origins is a journey into the unknown, a voyage that takes us to the very edge of what we can comprehend. It is a journey driven by our insatiable curiosity and our desire to comprehend the grand tapestry of existence, a quest that unites us all. Join us as we explore the scientific theories, the philosophical implications, and the enduring mysteries surrounding the birth of our universe, a journey that promises to expand our horizons and deepen our understanding of the cosmos. The idea that something can come from nothing might seem counterintuitive, even absurd. After all, our everyday experiences tell us that objects don't simply pop into existence. We don't see chairs, tables, or any other objects materializing out of thin air. We are accustomed to the idea of cause and effect, of things having a beginning and an end. Every event we witness seems to have a cause and every object a history. But the universe's origin story challenges these assumptions. It invites us to think beyond the conventional boundaries of our understanding. It forces us to confront the limits of our intuition and to embrace the strange and wonderful world of quantum physics. This realm is filled with phenomena that defy our everyday logic. In the realm of quantum mechanics, the rules that govern the universe at its smallest scales are vastly different from those we observe in our macroscopic world. Particles behave in ways that seem almost magical. Empty space, which we perceive as nothingness, is actually teeming with activity. It is far from being a void. It is a seething cauldron of virtual particles that constantly pop in and out of existence. These particles are ephemeral, existing for just a fraction of a second. These particles, governed by the laws of quantum uncertainty, borrow energy from the vacuum of space, exist for a fleeting moment, and then annihilate each other, returning the borrowed energy. This process is a continuous dance of creation and destruction. This quantum dance of creation and destruction suggests that the universe, at its most fundamental level, is not a static and unchanging entity. It is dynamic, constantly in flux. Instead, it is a dynamic and ever-evolving system where the boundaries between something and nothing are blurred. The universe is a place of constant change and transformation. The concept of nothing itself becomes slippery. What we think of as nothing may actually be filled with potential. Is it truly an absence of everything, or is it a state of potentiality, a quantum vacuum pregnant with the possibility of creation? This question challenges our very understanding of existence. Philosophers have long grappled with the nature of existence and the meaning of nothingness. Their debates have spanned centuries and continue to this day. From the ancient Greeks to modern existentialists, thinkers have pondered the relationship between being and non-being. They have sought to understand the essence of reality. In the context of the universe's origin, the question becomes even more profound. The birth of the universe is a mystery that continues to captivate scientists and philosophers alike. Did the universe emerge from a state of absolute nothingness? Or was there some pre-existing entity, a quantum field, or a singularity, from which our universe sprang forth? This is one of the most profound questions we can ask. The answers to these questions remain elusive, but by exploring the intersection of physics and philosophy, we can gain a deeper appreciation for the profound mystery of creation. This journey of exploration enriches our understanding of the cosmos and our place within it. The Big Bang Theory stands as the prevailing cosmological model for the universe's early development. It is supported by a wealth of observational evidence, including the redshift of distant galaxies, the cosmic microwave background radiation, and the abundance of light elements in the universe. This theory posits that the universe began from an extremely hot, dense state approximately 13.8 billion years ago. In an instant, space itself expanded rapidly, cooling and decreasing in density. This expansion continues to this day. Imagine the entire observable universe compressed into a space smaller than an atom. This tiny, incredibly dense point called a singularity contained all the matter and energy that would eventually become galaxies, stars, planets, and even us. From this singularity, the universe expanded and cooled, with energy converting into particles like quarks and electrons. As the universe continued to cool, these particles combined to form protons and neutrons, the building blocks of atoms. The Big Bang model doesn't attempt to explain what caused this initial expansion. It describes the evolution of the universe from a very early state, but the singularity itself remains a point of mystery. What were the conditions that led to this incredibly hot, dense state? Did time even exist before the Big Bang? These are questions that continue to puzzle cosmologists. Despite these lingering mysteries, the Big Bang Theory has been incredibly successful in explaining a wide range of observations. It provides a framework for understanding the universe's large-scale structure, the cosmic microwave background radiation, and the abundance of light elements. While it may not be the final word on the universe's origins, it represents our current best understanding of this profound event. The concept of time is so fundamental to our existence that it's hard to imagine a reality without it. Time governs our lives, from the ticking of a clock to the changing of seasons, and even the aging of our bodies. We experience time as a linear progression, a constant flow from the past to the present and into the future. This linear perception of time is deeply ingrained in our consciousness, shaping how we plan, remember, and anticipate. But according to the Big Bang Theory, time, as we understand it, did not exist before the universe began. The very fabric of time and space was created in that monumental event. It, along with space, came into existence with the Big Bang. This singular event marked the birth of everything we know, from the smallest particles to the vast galaxies. Before the Big Bang, there was no before because time itself did not exist. The concept of before is meaningless in the context of the Big Bang. The singularity, that point of infinite density, represents the very beginning of time. It was a state where all the laws of physics as we know them break down. As space expanded, so too did time, unfolding alongside the expanding universe. This expansion continues even today, with galaxies moving away from each other. This concept can be difficult to grasp because our minds are accustomed to thinking of time as a separate and independent entity. We often struggle to comprehend how time and space are intertwined. Think of it this way, just as the surface of a balloon expands as you inflate it, so too did space expand during the Big Bang, carrying time along with it. The balloon analogy helps us visualize how space and time are interconnected. There is no outside the balloon, just as there is no before the Big Bang. The universe is self-contained with no external reference point. Time is woven into the very fabric of the universe, an integral part of its structure. This intricate tapestry of space-time forms the stage on which the cosmic drama unfolds. This intimate connection between space and time is described by Einstein's theory of general relativity. His groundbreaking work revolutionized our understanding of the universe. General relativity tells us that gravity is not a force acting at a distance but rather a curvature in the fabric of space-time caused by the presence of mass and energy. Massive objects like stars and planets bend the space-time around them. In the extremely dense and energetic conditions of the early universe, gravity would have been the dominant force, shaping the evolution of both space and time. This gravitational influence played a crucial role in the formation of cosmic structures. So, the next time you gaze up at the night sky, remember that you are looking back in time. The light from those stars has traveled vast distances to reach your eyes. The light from distant stars and galaxies has traveled for billions of years to reach us, carrying with it a glimpse of the universe's past. Each photon of light is a messenger from a bygone era. And as you contemplate the vastness of space and the immensity of time, remember that both of these fundamental aspects of our reality were born from the Big Bang, a single event that set the stage for everything that is, was, and ever will be. This profound connection between time, space, and the origins of the universe continues to inspire and challenge our understanding.